Object-oriented programming was designed as a way to split up really large programs into individual silos. The idea is, rather than worrying about every variable and every function in the application, the code gets compartmentalized. So when, say, you're adding a new feature to that application, you only have to worry about code and data specific to that feature. Everything else is safely sectioned off and out of your way, and free from accidentally getting broken while other code gets updated. With OO programming, you can dictate not just what the code does, but also which other pieces of code can see it. You can explicitly state which functions are visible to the entire application, or only visible to one specific component, or specific groups of components, but nothing else outside of that group, and so on. This might seem kind of abstract and strange at first, but once you get used to it, it really does help making developing software go more smoothly, especially when dealing with really large code bases, and even more so when the code is worked on by several different developers at the same time. Most of what's done with object-oriented programming is collecting related variables and functions together into containers. In CFML, those containers are called components, or CFCs. You'll also hear them referred to as classes because classes is the OO term for pretty much every other object-oriented language out there. C++, Java, .NET, and bunches of others all call them classes. And we'll probably flip back and forth between saying classes, CFCs, and components in this video series. Another word you'll hear a lot, both in and out of CFML, is object. Sometimes class and object get used interchangeably, but that's actually incorrect. The component is the blueprint. It describes the type of data that will be built and which methods go along with it. The object is the actual instance of that component in memory. For example, in the code you see here, actor and employee are components. These are actual .cfc files that live on the server, describing what the data will look like and how it will behave. Over here in our index file, we have some sample code. A1, A2, E1, E2, and E3 are all objects, actual instances of those components. These live in memory and are used like any other variable in your application, the same as you'd use an integer, array, struct, string, or whatever. Of course, objects have some extra functionality beyond those other data types, and that's what we'll learn about in this video series. Objects can have as many variables or properties in them as you need, and they can have as many functions or methods as you need in them as well. The only limitation is the amount of storage available on your servers. Now, with potentially a large number of variables and functions inside each component, we could end up with a lot of code to manage. Another benefit of object-oriented programming is we can mark the variables and functions so that they're only visible in certain parts of the application. This cuts down on us accidentally using the wrong code and introducing bugs. It also increases our ability to reuse code in new ways. In this video series, you'll learn techniques such as data encapsulation, inheritance, composition, and more. They're all ways to take maximum advantage of the benefits you'll get by using CF components. And as an added bonus, pretty much all of the techniques we'll learn in this video series work in very similar ways across many other OO languages. So if you work at a place, for example, that also uses Java or C++ or .NET or some other OOP languages, most of what you'll learn in this video series will also translate across to those other technologies in just about the exact same way as you'll learn them here in CFML.